Diffraction. First question. What is the diffraction of light? The bending of light round the corners of an obstacle and spreading of light waves into the region of geometrical shadow of the obstacles is called as diffraction of light. आपण डेली लाईफमध्ये डायफ्रॅक्शन नाही बघू शकत बिकॉज ऑफ स्मॉल ऑब्स्टॅकल्स. सेकंड क्वेश्चन. Difference between interference and diffraction. First point. The interference fringe in a particular pattern may or may not be of the same width. The diffraction fringes in a particular pattern are not be of the same width. Second point. In interference, all the bright fringe has same intensity. In the diffraction, all the bright fringe has not same intensity. Third point. The points of the minimum intensity are perfectly dark. The points of minimum intensity are not perfectly dark. Fourth point. The contrast between the fringe is good. The contrast between the fringe is not good. Third question. Types of diffraction. त्यामध्ये दोन टाईप्स येतात. फ्रॅक्शनल डायफ्रॅक्शन अँड फ्रॉनहोफर डायफ्रॅक्शन. डायग्राम काढायची. सोर्स स्लिट स्क्रीन. परत सोर्स लेन्स आली स्लिट, लेन्स आली स्क्रीन. फ्रॅक्शनलमध्ये लाईट सोर्स अँड द स्क्रीन आर फायनाईट डिस्टन्स फ्रॉम द डिफ्रॅक्टिंग ॲपर्चर इज कॉल्ड एज फ्रॅक्शनल डायफ्रॅक्शन. फ्रॉनहोफरचं light source and the screen are infinite distance from the diffracting aperture. It is called as Fraunhofer diffraction. Fourth question. Diffraction grating. First point. ही एक अशी अरेंजमेंट आहे ज्यामध्ये सेम विड्थचे खूप सारे पॅरलल स्लिट्स ठेवलेले असतात आणि त्यांच्यात इक्वल गॅप मेंटेन केलेली असते. त्याला आपण डायफ्रॅक्शन ग्रॅटिंग असे म्हणतो. सेकंड पॉईंट. आपण हे डायमंड पॉईंटच्या मदतीने ग्लासवर पॅरलल लाईन्स ड्रॉ करू शकतो. थर्ड पॉईंट. हे लाईन्स एका सॉलिड वॉल्ससारखे असतात आणि या वॉल्समधून लाईट पास नाही होऊ शकत. ट्रान्समिशन ग्रेटिंगमुळे प्रत्येक इंचमध्ये 15,000 ते 20,000 लाईन्स असतात. फोर्थ पॉईंट. या ग्रॅटिनला फ्रॉनहोफरने शोधला. फिफ्थ पॉईंट. या लाईन्समध्ये जेवढा गॅप असतो आपण फक्त तेवढीच लाईट बघू शकतो. फिफ्थ क्वेश्चन. रिझॉल्विंग पॉवर ऑफ ग्रेटिंग. द रिझॉल्विंग पॉवर ऑफ ग्रेटिंग इज डिफाइंड ॲज द रेशो ऑफ द वेवलेंथ ऑफ एनी स्पेक्ट्रल लाईन टू द डिफरन्स इन द वेवलेंथ बिटवीन दिस लाईन अँड द नेबरिंग लाईन such that the two lines appear to be just resolved. त्यानंतर डायग्राम काढायची. ग्रेटिंगची. इन्सिडेंट लाईट, तर 4 इन्सिडेंट लाईट, अँगल काढायचं थीटा, देन डेरिव्हेशन लिहायचा. सिक्स्थ क्वेश्चन. एक्सप्लेन द एक्सपेरिमेंटल मेथड टू डिटरमाइन द वेवलेंथ ऑफ स्पेक्ट्रल लाईन युजिंग डायफ्रॅक्शन ग्रेटिंग or application of diffraction, determination of wavelength of light. First point. A diffraction grating is like a special tool which is used in the science labs. Second point. It helps to figure out the colors of light by the separating it into its different parts. Third point. It means we can see the different colors in the light from a specific source by using a special tool which is called as spectrometer. Fourth point. The spectrometer is first adjusted for parallel rays. Fifth point. Equations. In bracket a plus b bracket complete sin theta is equals to m lambda, where m is order, lambda is wavelength and theta is diffracting angle. Laser and fiber optics. First question. Explain laser with its characteristics and applications. First point. लेझर हा एक डिव्हाइस आहे जो स्पेशल लाईट प्रोड्यूस करतो. त्याला आपण लेझर लाईट असे म्हणतो. ही लाईट बाकीच्या लाईटपेक्षा वेगळी आहे. बिकॉज इट इज व्हेरी फोकस्ड मीन्स इट ट्रॅव्हल्स इन अ स्ट्रेट लाईन. सेकंड पॉईंट कॅरेक्टरिस्टिक्स. त्याच्यामध्ये फर्स्ट पॉईंट मोनोक्रोमॅटिक, सेकंड डिरेक्शन, थर्ड इंटेन्सिटी. फर्स्ट मोनोक्रोमॅटिक. लेझर लाईट ही फक्त एका कलरपासून बनलेली असते. सेकंड डिरेक्शन. लेझर लाईट एका स्ट्रेट लाईनमध्ये ट्रॅव्हल करते आणि ती स्प्रेड नाही होत. थर्ड पॉईंट इंटेन्सिटी. इट इज व्हेरी इंटेन्स. थर्ड पॉईंट ॲप्लिकेशन. फर्स्ट सर्जरी, सेकंड कटिंग, थर्ड वेल्डिंग, फोर्थ मेजरमेंट. Difference between spontaneous and stimulated emission. First point, spontaneous emission does not depends upon the higher and the lower energy level state. Stimulated emission depends upon the higher and lower energy level state. Second point, it is random process. It is not random process. Third point, cannot be controlled from outside. Can be controlled from outside. Fourth point, light produced by this process is non-directional. Light produced by this process is directional. Fifth point, light by this process is unpolarized. Light by this process is polarized. Sixth point, spontaneous emission describes LED operations. Stimulated emission describes laser operations. Third question, explain metastable state. In case of the stage to which the atom is excited is a metastable state, then the atom stays there for a long time. This process is very important for population inversion. Fourth question, population inversion and state its significance in the operation of laser. First point, definition. A state in which the number of atoms in the higher energy level is more than the number of atoms in the lower energy level is called as population inversion. Second point, significance. त्यामध्ये first point, for light amplification the stimulated emission is required. Second point, in addition to the stimulated emission the absorption and the spontaneous emission is also present. Third point, at the normal condition the spontaneous emission is more than the stimulated emission. Then diagram काढायची. लाईटचा फोटॉन E1 E2 एनर्जी लेवल 1 एनर्जी लेवल 2 फोटॉन येतो पण बाकीचे सगळे हे वर जातात. पॉप्युलेशन इन्व्हर्जन अचीव होते. फिफ्थ क्वेश्चन states Einstein's equation. We know the theory of relativity E is equals to mc square. This shows how the energy and mass are related. Sixth question, what is the pumping in the laser? Give the types. First point, a state in which the number of atoms in the higher energy level is more than the number of atoms in the lower energy level. This process is called as pumping. Second point, types. First, optical pumping. Second, electrical pumping. Third, chemical pumping. Fourth, direct pumping. Seventh question, what is the resonant cavity? First point, resonant cavity याला optical cavity किंवा laser cavity पण म्हणतात. Second point, it is defined by the two mirrors which is used in the laser fabrication. Helium neon laser. 8th question, helium neon laser. Diagram काढायची. Construction. First point, this is a gas laser which uses electrical discharge or pumping. Second point, the mixture of helium and neon material is used. Third point, it is basically consists of long discharge tube about 30 to 50 cm in length and 1 to 2 cm in diameter. Fourth point, this tube is sealed at the both ends by inclined glass window called Brewster's window. Fifth point, this glass tube is filled by the mixture of helium and neon in the portion of 10:1. Sixth point, We are placed two mirrors along the Brewster's window. One is fully reflecting mirror and other is partially reflecting mirror. Seventh point, a high voltage is applied between the anode and the cathode, which act as a pumping source. Working ची डायग्राम काढायची. एनर्जी लेवल ऑफ हेलियम, एनर्जी लेवल ऑफ निऑन. ठीक आहे. फर्स्ट पॉइंट, the energy level diagram is shown. Energy level of helium is used for pumping and energy level of neon is used for laser transition. Second point, the electric discharge ionizes some atoms in the mixture and these atoms gains kinetic energy. Third point, the helium atom takes most of this energy and it will go to the excited state. Fourth point, after that helium atoms comes to the ground state by transferring their energy to the neon atoms and neon atoms get excited. Fifth point, thus the population inversion is achieved between E6 to E5, E6 to E3, E4 to E3 and E5 and E3 are the metastable state. Sixth point, the output wavelength in this transition are E6 to E3 is 6328 Armstrong unit, E6 to E5 is 3.39 μm, E4 to E3 is 1.15 μm. Ninth question, Nd:YAG laser कन्स्ट्रक्शनची डायग्राम काढायची. कॅपॅसिटर, बँक, पॉवर सप्लाय, बॅलेस्ट, रेजिस्टर वगैरे. First point, it is basically a solid state laser in which yttrium ions are replaced by neodymium atoms. Second point, in this the crystals do not take part in the lasing actions but it serves as host for active center. Third point, it consists of elliptically cylindrical reflector system in which Nd:YAG rod is placed along one of its focal line and krypton lamp is placed at the other focus. Fourth point, a high potential difference is applied between the two ends of krypton lamp. Fifth point, we are placed two mirrors along Nd:YAG rod. One is fully reflecting mirror and other is partially reflecting mirror. Sixth point, using elliptical reflector, light is coming from one focus of elliptical reflector will pass through the other focus by multiple reflection which gives optical pumping. Working diagram काढायची. Pump, higher energy level, laser output, energy level 1, 2, 3. First point, in Nd:YAG laser, Nd3 plus is active center. The energy bands of neodymium are shown in the diagram. Second point, when the krypton lamp is on, optical pumping starts and emits the light in all wavelength region. But out of that, Nd:YAG rod absorbs the light of wavelength 730 to 760 nanometer and goes to the excited state. Third point, from excited state, atoms falls down to the energy level E3 which is metastable state. Fourth point, thus the population inversion is achieved between E3 to E2. Fifth point, as the time goes on the population of E3 goes on increasing. Sixth point, the atom comes to the ground state E2 by emission of light of wavelength 1064 nanometer which is in infrared region and not visible to the human eye. 10th question, explain the construction and reconstruction of image in holography with neat diagram. Holography is a technique that enables a wavefront to be recorded and later reconstructed. There are two steps of holography. First, recording of hologram and second, reconstruction process. First, recording of hologram. Diagram काढायची. Laser, fully reflecting mirror 2, partially reflecting mirror 1, photographic plate ऑब्जेक्ट बीम, रेफरन्स बीम. ठीक आहे. फर्स्ट पॉइंट, a monochromatic source of light is incident on partially reflecting mirror which divides the beam into the two parts. Second point, one beam is sent to the object and other beam is directed towards the photographic plate. Third point, the photographic plate is held such that it receives the light from object and the laser. Fourth point, the beam which is from object is called as object beam and the beam which is from the laser is called as a reference beam. Fifth point, these objects and reference beam are interfere with each other and produces interference pattern on the screen. Second, weaving of hologram. Diagram काढायची. Photographic plate act as a diffraction grating. Observer, virtual image, real image, diffracted rays. First point, in order to view the object, the light is incident on the photographic plate which contains information about an object in the form of interference pattern. Second point, photographic plate act as a diffraction grating producing diffraction pattern. Third point, this diffraction pattern is called as hologram. Fourth point, when we change our angle of view, thus we can see the different section of the object. Therefore, we can say that holography produces three-dimensional image. 11th question, difference between holography and photography. First point, holography produces three-dimensional image, photography produces two-dimensional image. Second point, it requires monochromatic source of light. It does not require monochromatic source of light. Third point, image is constructed from each part of the object. Image is constructed only for that part from which the light is reflected. Fourth point, large amount of information can be stored, small amount of information can be stored. 12th question, optical fiber with its applications. First point, physically optical fiber is very thin, flexible and having a cylindrical shape. Second point, it has total 3 sections. First, core. Second, cladding. Third, buffer coating or jacket or sheath. Third point, applications. First, telecommunication. Second, internet. Third, data transfer. Fourth, phone calls. 13th question, difference between step index and graded index fiber, SI and GRIN. First point, light travels in straight path, light travels in curved paths. Second point, lower bandwidth, higher bandwidth. Third point, commonly used for short distance, commonly used for long distance. Fourth point, simple design, complex design. Fifth point, cost is low, cost is high. Sixth point, core has uniform refractive index, core has varying refractive index. 14th question, numerical aperture NA with formula. It is defined as the light gathering capacity of an optical fiber and it is directly proportional to the acceptance angle. Formula, NA is equals to in root mu 1 square minus mu 2 square. 15th question, acceptance angle with formula. Any light wave is incident on the core. Within this, maximum external incident angle theta 0 is coupled into the fiber and will propagate. This angle is called as angle of acceptance. Formula, I is equals to sine inverse in bracket NA bracket complete. 16th question, V number. V number आपल्याला सांगतो की किती चांगल्या प्रकारे ऑप्टिकल फायबर इन्फॉर्मेशन कॅरी करेल यूजिंग लाईट. इम्पॉर्टंट फॉर न्यूमेरिकल्स, फ्रॅक्शनल चेंज रिफ्रॅक्टिव्ह इंडेक्स ला डेल ने इंडिकेट करतात. कोर N1, क्लॅडिंग N2, रेडियस ऑफ कोर A, वेवलेंथला लॅम्बडा. Formula: fractional change refractive index del is equals to n1 minus n2 upon n1. Second, numerical aperture in bracket n1 square minus n2 square. Third, acceptance angle I is equals to sin inverse in bracket na bracket complete.